All right, hello everyone. We are going to go through the process of what is sort of expected when you are graphing by hand and what you can and can't do, and what the expectations are for the AP test and for just, general good data analysis. I am going to use my sample data to make a graph on this video and sort of talk through the important things you need to do. If you just sit down and watch this video, it's going to be sort of like a long plotting video of watching me do the same assignment you need to do. What I think would be a better use of your time is to work at the same time as me. And if I get a little ahead of you, then just pause the video, and then once you are ready, you can hit play again, and that way we'll finish around the same time, and that'll be a significantly better use of your time. So, when you come back to school in a week and a half here, I will have a lab notebook for every one of you that will be full of graph paper, and it will be what we do all of our future labs in, and it will have graph paper built into it. For this analysis, you need to come up with either a piece of graph paper or something that can be used in place of a piece of graph paper. We can be pretty flexible here. Obviously, if you have graph paper, that's the easiest. There is a file of, if you have a printer at home, you should be able to print the graph paper file that's on Schoology and use that as your graph paper. If you don't have a printer and you don't have any graph paper, that's fine. You can actually just use lined paper. If you just take and line up two sheets of paper, I don't know if this is showing up on the camera, but I can see the other set of lines through this. And then you can just put some tape down or something, and you can just use this as graph paper. And it's obviously not the greatest thing, but it's going to get us through this lab and anything that we need to do for the next, week and a half. So find something that you can use as a piece of graph paper. Okay. When we graph, one of the things that you need to do is make sure that your graph fills up as much of the page as possible. On the AP test, you will not get credit when you are graphing by hand if you scale your axes in such a way where it fills up basically less than half the page, vertically or horizontally. And so at the very, very least, if you could have your increments and fill up twice as much space and still fit everything on the page, you should definitely do that. And the reason we need to do that is because when we are putting our best fit line on and trying to find a slope, the larger the graph is, the easier it will be able to resolve exactly where the best fit line is, and the easier time we will have getting a high quality slope and intercept for our fit line. The graph we are going to make is a graph of circumference as a function of diameter. So we'll label along the top here. Circumference as a function of diameter. And like we talked about in the question of the day, the way that we always set up our axes is it's the y value as a function of the x value. So circumference is going to go on our y-axis, and I need to pick an appropriate scale for my circumference. And so if I look at my circumferences, they go up to 77.6. So let's just see how many lines I have available. Probably don't want to go below here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. Okay, 40. So I can get 39, I've got 39 lines, and so I should be able to do 2 per line and get to 78, and that'll work. So my vertical axis, I'm going to go, each box is going to be 2. For my diameter, my biggest value is 24. So we've got at most here, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 would get me to like right here. And so I'm just going to go 1 each box will be one line, and that'll work. Although you want to try to fill up as much of the page as possible, you don't want to be ridiculous about it. So like, obviously I can't do 2 per box and make everything fit along my x-axis, but maybe like 1.2 per box would fit or something. That's difficult to actually do like good graphing on and fit a trend line on and stuff. Pick numbers that are actually easy to work with. Whole numbers, generally things that are divisible by like 2, 4, 5, something that's easy to visually break down and read is going to be good. And like I said, it just needs to be within reason. The best you can do to fill the page. If it's less than half the page, you definitely need to double your increments. So I'm going to use a ruler as my straight edge because I have one. And if you have a straight edge, that's awesome. If you don't, you can make one really easily. If you have a sheet of paper, just take and fold it, make a nice crease, fold it again. We'll go one more time. And now you're going to have a nice bead along here that you can use as a straight edge that'll hold your pencil really well, and you can just make nice, really straight lines with it. So if you have a ruler, use that. If you don't, make a straight edge. We're just going to set up our axes quick. And so I'm going to do that, and you should do the same. So you can go ahead and work on that while I work on this. I also want to make sure that I actually label my axes so I know what is what and, most importantly, what unit they're in. Yes, the title, if it is written in the right order, should tell you how the graph is made, but we always want to make sure we label our axes as well. And so circumference is a function of diameter, y is a function of x, so this is going to be my y value. So along my y-axis, wherever I have space, circumference. And then in parentheses, I want to make sure I indicate the unit. So this is in terms of lines, because that's what we measure our circumference in. Same thing for diameter, wherever I've got space for that. All right, and so we've got our basic setup here. And now I need to graph my data points, and I want to graph just as precisely as I can. And so my first one, my pen, had a diameter of 1.2 and a circumference of 4.0. And so this is 1, 2, so 1.2 is going to be a fifth of the way over. Each line is 2, so 4.0 is going to be right there. And I'm just going to make a little dot. A big enough dot that you can tell that it's actually supposed to be a dot and it's not a stray pencil mark, but not like so big that you can't tell where it's centered. If when we draw our trend line on here, there's going to be a line on here and you want to still be able to see your dot, but don't make it any bigger than it needs to be. So you're going to go ahead and get all 5 of your data points onto your graph as precisely as you can by hand. All right. And when you are done graphing, you should have something that looks sort of like this. An axis with labels with units and 5 nice dots. On the AP test, there is usually a lab question that requires you to do some graphing. And believe it or not, you actually get several points for just doing what we've done here, which isn't real complicated analysis, and so those are basically free points that everyone should get. But you have to make sure you set your axis up, make sure it's scaled appropriately, make sure everything is labeled clearly so we have numbers indicating what's on the axis, or what values are on the axis, and we also know what variable is being graphed and what unit everything is. And usually they give you a point for just plotting all of the data correctly. And so if you have managed to get your 5 dots into close enough to the right place that any person looking at it can't that it would look like you have the right numbers, then you get credit for that as well. Now the next thing we need to do is add a trend line. The reason that we use graphs in physics is because having a large amount of data allows us to draw a better conclusion about a relationship, but we want a single mathematical way to describe all of our data points. We don't want to do a relationship for this one and 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 then average the 5 of them together. One, that's really cumbersome and takes a long time, and 2, it actually gives us worse results than just using a graph correctly. And so we are going to try to draw a trend line, a best fit line on here that matches our lines as best as possible, because the equation for that will describe all of the data points better than anything else we can do with them individually. Now, when you draw your trend line, you want to draw the best possible trend line that goes sort of through the center of the pattern. You have a good trend line if about half of your dots are above it and half of your dots are below it. Now, since we only have 5 dots, it's not going to be, it doesn't have to be exactly 2.5 and 2.5, but you do not want to just try to blindly connect 2 dots and be like, oh, well, that would look nice if I just connect my 2 endpoints. Yeah, that's reasonably close. Don't do that. If it happens to go through a data point, that's fine, but most of the time your trend line will not actually hit a data point. And so you want to find the best straight line you can draw that seems like the best fit through all of your data. So I'm going to draw... Also, your trend line does not have to go through the origin. In fact, most of the time it won't go through the origin, and you should never, ever, 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 ever force your trend line to go through the origin. If your trend line hits the origin perfectly, that is usually a sign that you have graphed incorrectly. If it happens to go through the origin, that's great. Most of the time it won't. So everyone needs to use a straight edge and, sort of like I did here, draw a single line that is, as far as you can tell by hand with your eye, a single straight line path that seems to be the best average path that the data is on. Now we need to figure out the equation for this line. And so to do that, we're going to find its slope first. And slopes, it turns out, are the most useful thing we get out of these graphs. The y-intercept can have some value. The slope is really the thing that matters the most. And the way you find the slope is by finding the rise over the run with 2 points. You, in order to do this, need to pick 2 points that are on your line, and they cannot be data points. Do not use 2 of your data points as the points you use to find the slope. If you do that, even if they appear to be on your trend line, you will not get credit on the AP test most of the time for the way it is graded. The other thing I want to do is pick 2 points that are far apart. So I don't want to pick 2 points that are really close to each other. I want to get 2 points that are about as far out on the ends of the line as I can. However, you can use a little discretion if you can find a point that seems a little bit easier to measure. That is okay. Let me see if I can find an example here. So like right here, this line appears to be crossing right in the center, right in the middle. And so that I can pretty easily tell is going to be about 23.5. And so I'm going to use that point rather than an endpoint where it might be harder to estimate exactly, you know, what this is at. I can tell that's right in the middle. And so it's still on the end. It's still going to give me a good result. But I'm going to pick this point because it's a little easier to work with, but I'm still picking something out on the end. I'm going to write down my coordinates because I need to make sure that I'm showing my work clearly. That's one of the things that the AP graders look for, and certainly if you are working as a scientist or an engineer or something, other people need to be able to tell what you did. Otherwise, you don't get paid, you just get fired because you need to be able to work with other people. This coordinate is 20, what did I say? 23.5? And it's right on the line, which is again going to make it easier to get a good number for this. These are each 2, so that's going to be 74. And I can tell it's not just like closer to 74 than anything else, it's right on the line. And so just like I put the 0.5 in here to indicate, you know, where we are in between, I'm going to use 74.0 to indicate that I really know I'm within a 10th, maybe a 20th of that line. It's not just close to 74, it's 74.0. And that, again, you know, from chemistry, you should know is what our significant figures are for. How many decimal places you go out to tells us how accurately we trust that number. I'm going to go find another point down here. What looks good down here? There's not a lot of super great ones. I'm going to maybe pick this point right here. And so again, I want to clearly mark what point I'm using. My x value, it's going to be about 2.4. And my y value, it's right on the 8 line, so we'll call that 8.0. And so now I've got my two values that I'm going to use to calculate the slope of my line. So 2.4 and 8.0. And 23.5, 74.0. What you need to do is you need to show your work, calculate the slope, figure out what your y-intercept should be. You should be able to visually verify that the y-intercept you calculate should look something like what you actually got, you know, if you just followed it to what the y-intercept is. And so you're going to show your work and find in the equation, so y equals mx plus b, find an equation in y equals mx plus b form. So you need to, for your values, calculate what your slope is and what your y-intercept is, and then write it out as y equals mx plus b. And that is what we will need for the start of our next lesson.